Today's lesson is going to be on nomenclature of acids. Okay, so we've looked at in the past the nomenclature of ionic compounds, including polyatomic ions. So the thing with acids is they're going to follow pretty much the same pattern, but they can be a little misleading because of the way the formula looks. Now, if you remember, we wanted to distinguish between ionic compounds and molecules. Well, ionic compounds always had a metal and a nonmetal in them. Two nonmetals would always give us a molecule. Okay, so that means you're going to have two different naming systems. Ionic compounds, if there's a metal and a nonmetal, for example, if you have something like sodium chloride, that would follow the ionic rules because we have a metal and a nonmetal. If we have something like CO2, well, because we have two nonmetals in here, we would name this using the molecular rules. Now, we haven't talked about the molecular rules yet, and we're going to talk about that in the next lesson. The reason I'm bringing this up is that because when we look at something like hydrogen and chlorine together to make hydrochloric acid, it looks like it's a molecule because it's two nonmetal atoms put together. But the problem is that it's made up of hydrogen and chloride ions. The thing about acids is they look like molecules, but they behave like ionic compounds. Okay, we're going to talk more about the difference between ionic and molecular throughout the whole year, but that's just one of the things with acids. Now, how do you know if it's an acid? Well, I'm going to tell you. That's how you're going to know, because the rules can be a little misleading because it looks like it's two nonmetals, so you can use the same naming system for molecules. So, if I want you to give me the name of the acid, I will be specific and say, name the following acids. Some teachers use this little notation called AQ, which means aqueous, which means that it's dissolved in water, because they're under the impression that an acid only has acid properties when it's dissolved into water. I don't use that notation for acids. I will specifically say, name the acid or give me the formula for the acid. If I don't, I will accept either the molecular name or the acid name. I'll explain that as I look at some examples. So let's go further here. Acids, what are they? Essentially, it's a molecule that has one or more hydrogen ions that are going to be released when it's dissolved in water. So because it has this hydrogen ion in it, it's going to make it very similar to ionic compounds. We're going to have to balance charges is what this means. So for acids, we have to balance charges. Okay, so we don't want to forget that we have to balance the charges in here, okay? So I'll show you that as I look at some examples. The acid name is always going to depend on the anion because your cation is always hydrogen. So they're going to start HCl, they're going to start H2SO4, they're going to be HC2H3, O2. If you see a hydrogen in the front, you're most likely dealing with an acidic substance. Now, if you notice that the ones I chose here, they're going to fall into two types or two categories of acids. One that contains an oxygen and another that does not have an oxygen. So if I look at this substance here, I'm looking at that anion, right? Focusing solely on anions because the hydrogen ion is going to always be there in the beginning. Right? So we're not going to really necessarily need to use this because if we say acid, we know that the hydrogen is in the front. So our name is really going to depend on what that anion is in our formula. So take a look at the difference. We've got chlorine, which is really a chloride in this compound here, and we've got sulfate. This one contains oxygen, the sulfate, and the chlorine over here has no oxygen. So there's two different ways to name, and it's very important to pay attention to this because it's all in the amount of oxygen that's in the substance. So if it's going to contain oxygen, it's most likely a polyatomic ion. Okay, so let's take a look. All right, here's the rules for naming acids that do not contain oxygen. So if there's no oxygen, this is the pattern you're going to follow. You're going to put a prefix in the front here. There's going to be a root from the word, from the anion, right? So the root is going to come from the anion name, and you're going to add a suffix. And then you throw the word acid at the end, okay? So hydro is the prefix that we use, chloric acid, and that would be HCl. Prefix is hydro. Now what does hydro mean? It tells us there's no oxygen. Be very careful with this. Students get very confused with this. Hydro means no oxygen. So as soon as you see a name with hydro in it, you know that we are dealing with an element that has no oxygen. Essentially, it's going to have a monatomic ion in there. And really, your only choices are chlorine, fluorine, bromine, iodine. I'm kind of forgetting some of them offhand, but okay, so that would be able to give you sulfur or sulfide. You would have phosphide, nitride. There's really not many choices for these, to be honest, because it has to be a single element because it cannot contain oxygen. So if I were to look at this formula here, now that should be H2S. My subscript got erased there. So it's H2S. So there's no oxygen. So I'm going to say hydro is my beginning because there's no oxygen. So when the person is reading my name, they're going to know that I'm talking about the anion. Well, which anion am I talking about? Well, it's the sulf, right? Now, here's where things get a little confusing because students are like, well, wait a minute. You're supposed to put the root in here. But for this one, I'm going to put sulfur, hydrosulfuric acid. Okay, so I have in here my prefix, which tells me there's no oxygen, and I put the ic ending on here. So how come I didn't call it hydrosulfic acid? It's just the way it is. I can't really explain it other than that's just what scientists call it. They don't really call it hydrosulfic acid. I will not take points off if you didn't put the UR. I would remind you, and think about it. Does it sound right, hydrosulfic acid, or does it sound better to say hydrosulfuric acid? So it'll come with experience, so I'm not too concerned about that portion right now. I'm more really looking at that you understand hydro, ic, sulfur, and then the acid. So hydrosulfuric acid. So if I were looking at HBr, again, no oxygen in the name, so I would do hydro prefix, okay, hydro, and then I would do the brom. And this is one that actually has the root part of it, the ene is taken off. So hydrobromic acid. And again, notice the pattern. Pattern is prefix, ic, and brom. Okay? All right, so that's oxygen, or the acids that have no oxygen in them. Okay? All right, so let's take a look at what the ones that do have oxygen in them. This is the one that gets a little confusing. Okay, and the reason why it gets confusing is because we have a little change that has to happen. So if it does contain an oxygen, the problem is that you have these two options here. You have H2SO4. Now if you think about the last one that I did on the last slide, there was only sulfur. There was no other choice. But because I have polyatomic ions, I have a choice between ates and ites, right? I have a sulfate and I have a sulfite. And that's going to have a huge impact on how I name this because I got to make sure that I tell you that there's 4 oxygens and 3 oxygens. Now, if you memorize your polyatomic ions, you're going to remember that SO4 2- is sulfate. Okay? And then, of course, you should know that the SO3 2- is sulfite. Okay? So what I'm going to do here, since I'm focusing on the anions, I'm going to focus on the endings here. So, first of all, no prefix is used. Why? Because there's oxygen here. So you don't call these hydros. So that's a big indicator when you're looking at writing the formulas from the names. So I'm going to call this sulfur acid, some kind, right? But I have to make sure that I tell you that it's the 4. So I'm going to change my 8 to an ic. So this would become sulfuric acid. Sulfuric acid. Okay, by having no hydro in the beginning, it tells me that there's oxygen in here. The ic ending is going to tell me that that was an 8. So this gets a little confusing, I understand, but you're going to have to practice this a little bit. So this is that the 8 ending from the sulfate. So over here I would call this sulfurous acid. Not sulfus acid or sulfic acid, but sulfuric and sulfurous. Again, the OUS ending here is now telling me that I had an ite in my polyatomic ion. So an ITE ending is where that originates from. So your ates become ic, your ites become us. Now I think there's a mnemonic device. I think it was I ate something icky. and there's a light on in the house, I think Miss Ruther uses. If you remind me in class, I can try to tell you, but you know, that might be something to help you remember. That was, I ate something icky. I mean, that one's pretty much all you need to remember, because then you can derive the other one from that. But I think it's a light, misspelled light, by the way, like the, you know, L-I-T-E kind of light. Even that's bad spelling. Anyway, light on a light is on in the house. Okay, and that gives you the OUS. All right. So if that helps you, that's great. If not, let me know and I can try to help you with that as we move along. So let's go ahead and write the formulas from the names. So I'm going to go backwards. What I was doing before is I gave you the formulas and we wrote the names. So from here, I'm going to go ahead and decipher this and write the formula. So what I'm going to do here is I'm looking at hydro. So if I see hydro in the beginning, right away that tells me that there is no oxygen. So that means that there is no polyatomic ion. So that means what I have is just a monatomic ion, and that monatomic ion is sulfur. And what's the charge on a sulfur? 2 minus, because remember from your periodic table. So when I write the formulas, I've got to balance the charges. So I have a sulfur, which is 2 minus. Hydro doesn't necessarily mean there's hydrogen in there. We're just using that as a way of figuring out if there's a polyatomic ion or not. Every acid is a hydrogen ion. So as soon as I see acid, I right away think, oh, my cation has to be a hydrogen. So therefore I have a +1, 2 minus, and my formula has to be H2S to balance out that charge. Okay? All right, let's try the next one here. Nitrous acid. Okay, there's no hydro in the beginning. Since I don't have a hydro there, that means that I have a polyatomic ion in this acid. Okay, so what I have to do is I have to decipher the OUS ending. As soon as I see that OUS ending, I'm right away going to change that to ite. Right, so that's going to tell me that I have nitrite, and a nitrite is NO2 minus. Okay, if you don't have those polyatomic ions memorized, you're going to be going nuts here. So you should really have those memorized at this point. So if I have NO2 minus, I'm going to write that as my anion, and I'll put in here my hydrogen ion as the cation. And again, I just balance the charges. So in this case, I would just do HNO2. And that would be my nitrous acid. Notice the difference here. No prefix, polyatomic ion. Prefix of hydro, monatomic ion, a single element. Now this is one that throws students off right away because they're not reading it carefully. This doesn't say hydrochlorous acid, this says hypochlorous. So that is not the hydro prefix, so be very careful with that. So I don't have a hydro prefix. This is going to be a polyatomic ion. Since it's hypochlorous, I'm going to change that us to an ite. So hopefully you remember that hypochlorite is ClO minus. Alright, so I just have to throw a hydrogen in the front of that. So H plus ClO minus gives me HClO. A lot of people will answer this one, and this is what I'll get for the answer. I'll get HCl because they think that's hydrochloric acid. Wait a minute, that's not ick, that's us. So it should get you, if you're going to memorize anything, memorize this one. Memorize hydrochloric acid as HCl, because that is going to be your correction for all these rules. Hydrochloric acid, there's no polyatomic ion, hydro beginning, ic ending. It's a good one to remember. The other good one to remember is H2SO4. These are very common acids in chemistry. Hydrochloric, sulfuric. If you remember those two, it'll help you to remember all the rules. That was pretty much what I did when I was in school. I just kind of remembered those two to help me. So again, no hydro prefix. So therefore, I'm going to have a polyatomic ion. Okay, so if I change that polyatomic ion, the ic ending to 8. Okay, so it gets a little confusing because of that OR that's in here, right? We probably take that out. We get phosphate. And hopefully you remember that phosphate is PO4. 3 minus. I have to throw my hydrogen in the beginning because it's an acid. So therefore, to balance this, H3PO4 is my acid formula. Okay? Alright, so let's go ahead and move to the last part, which is to just name them. I'm not going to name all these. I'm just going to pick a few out. We'll do some more of these in class. I already told you what this one was. We'll skip this. That's sulfuric acid. Everybody should know that one. Okay, go practice that one. If you have questions on it, I'll look at it in class. I think we did this one too, but let's go ahead and do it anyway. I'm writing the formulas. I'm writing the names from the formulas. What I'm looking for is oxygen. Since there's no oxygen here, I'm going to start with the prefix hydro, because hydro tells the person who's reading your name that this is a acid that has no polyatomic ion in it. So hydrobrom, and then I add ic acid. Okay. All right, down here I do have an oxygen, so therefore this is a polyatomic ion. So the first thing to do is to decipher what that polyatomic ion is. ClO3 minus is chlorate. Okay, so you should know what that name is. What I'm going to do here is I'm going to take the 8 off, and I change 8s to X. So what's the name of this acid going to be? It's going to be chloric acid. Okay, so chloric acid, not hydrochloric, but chloric. Okay, so make sure you analyze those and remember those. Okay. Now, this is one that's a little confusing because students right away go, wait a minute, this is a polyatomic ion. Okay, but remember the rule is oxygen has to be in there. There has to be an oxygen. Since there's no oxygen, you're going to right away put down hydro. Okay, and now this Cn minus, okay, is going to be your cyanide. Oops. So what I have to do is I'm going to change this. Since I have a hydro in the beginning, it doesn't matter. I really don't have to decipher the 8s because there is no 8 or ite. So I just follow the rules that I did for HBr, and I write hydro cyanic acid. So I just do the same thing. Hydro ic when there's no oxygen. When there's oxygen in there, no prefix. Ic if it's 8, us if it's ite. And there's your rules for naming acids. So practice, and we'll look at this in class. Thanks a lot.